Okay, so now we can see yes. So so you can definitely so you can find out the result that 3.12 is greater than 3.46. So you will reject your null hypothesis. That means your medicine has a effect uh, on your the difference. You are having different you will have obviously different population mean, so obviously your medicine will affect differently in the three different groups. Okay, for example, you have taken the group of I mean, suppose uh, the young and very young and the middle-aged and the old-aged people. Okay, so the medicine will have medicine will make a difference. Okay, in the different uh, age groups, it will be the different cholesterol uh, level, or that means it will affect, but their mean value that will not be same. So the medicine will have an effect. Okay, so now the problem is that in this case, you can understand that obviously the group means they will not be the same. Okay, the three group means they will not be the same. But which particular pair is different, or if all the pairs are different, that you cannot understand from just only from the ANOVA. Okay, so you need to conduct post hoc test. Okay, so that I am going to tell you. So just have a look at this example. So in this example, you have suppose different levels of income. You have, this is income level, this is your dependent variable, and your independent variable is the degree. Okay, for example, the school level, then the vocational level, and the college level. Okay, sorry, college level means degree level, and there is another group who does not have any qualification. Okay, so you would like to, and the annual annual income, these things are also given. So you would like to test that whether these uh, these groups, okay, whether these particular groups, they have different means or not, that you would like to test. Okay, they have whether they have some different means or not, that you would like to test. Okay, in terms of the population. So you need to conduct ANOVA. Okay, and obviously this will be one-way ANOVA. Whenever we are using the term that ANOVA, ANOVA means simply one-way ANOVA. One-way ANOVA means there will be one dependent variable and there will be one independent variable. Okay, but if there are, suppose if there is one dependent variable and two independent variables, then you will say that that is two-way ANOVA. If there are there is one dependent variable and three independent variables, then you will say that this is three-way ANOVA. Okay, so like that. In that way, you can consider n-way ANOVA. But and also later on we will discuss a concept of MANOVA, or multivariate analysis of variance, and there you will have only one independent variable, but there will be more than one dependent variable. Okay, so suppose if there is one dependent variable, one independent variable, and there are two dependent variables, then we will say it two-way MANOVA. Okay, so now we are discussing on simply one-way ANOVA. Okay, so after performing one-way ANOVA, you can see that your null hypothesis, and this is that all these means are population means are same, and your alternative hypothesis or research hypothesis are that not all the means are the same. Okay, so that you can see, but not all the means are the same. It does not mean, it doesn't necessarily mean that all the means are different. It may be or may not be. Okay, so which particular means are same or which particular means are pair of means are different, so that you need to understand. So what you will do, you will perform a post hoc test. Okay, in this case, and this is only applicable if your null hypothesis is rejected. Okay, if your null hypothesis is not rejected, that means you are concluding that there is not enough evidence that the means are, the population means are different. Okay, so there is no need to perform any post hoc test. But if your null hypothesis is rejected, then only you will perform your post hoc tests. So in your post hoc tests, whatever you are in post hoc test, what you are seeing, you want to perform in as post hoc test, you want to perform actually Cohen's d test. It is termed as Cohen's d test. Okay, so if you perform Cohen's d test using Minitab or any kind of software, it will give you the p values that you will find. Okay, so you can see that none and school, none and vocation, none and degree, school, vocation, school, degree, vocational degree. So all these pairs you can individually, you can compare, and you can check out their significance level. So you can see that in all the pairs for none and school, that means the group, those who have no education at all, and the group who have done school level. Okay, if you compare them, okay, so there is a significant difference in terms of salary if you compare the school level and no education level group. Okay, if you compare suppose the vocational degree and those who have proper degree like BTech or bachelor's or master's, you can see that there is a significant difference in terms of salary. Okay, but the school level and vocational level, those who have school level degree and those who have vocational level degree, in this particular pair, for this particular pair, there is not enough difference in terms of the salary, okay, at population level, because your p value is 0.876, which is greater than 0.05. Okay, so that's why your conclusion is that the first is that all the population mean, there is enough evidence that for different qualification level, the salary will also vary. Okay, this is your first conclusion. And your second conclusion is that the variation exists in all the cases except the school level and vocational level comparison, this pair. Okay, that means the school level and vocational level people, they do not have much difference in terms of salary at population level. Okay, so this is a very good example. Okay, so now there are also some assumptions of ANOVA, like independent samples well modeled by a normal distribution, variance of group means. If violated, then use non-parametric test or Kruskal-Wallis test. Okay, but so far I have seen that even uh, the data, they are not normally distributed. Usually it doesn't differ too much. Okay, it doesn't differ too much. There are some assumptions of ANOVA, like the samples must be independent of each other, well modeled by normal distribution, variance of group should be same or closer. Okay, for example, suppose you can see that the variance, the mean are given, the standard deviation are given, this n sample size is given, and you can see that in case of the degree, okay, in case of the degree, you can see that the standard deviation, it is very high as compared to these three levels. Okay, so in this case it is sometimes ANOVA is not preferable, but still I have seen that the 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 way some tests are there instead of ANOVA, which is known as Kruskal-Wallis test. Okay, in the same way you need to perform the Kruskal-Wallis test, because you will be interested, you will perform everything in software, and you will be only interested to know about this p value, nothing else. Okay, even if you do not know nothing calculation, you can perform the test. Only you need to know that when I should perform the test for which particular purpose, that's it. Okay, so if you face these kinds of things, if you find that the ANOVA is not applicable, okay, so in that case, instead of ANOVA, you can perform Kruskal-Wallis test. But as you can see, and we have seen that in most of the cases, that ANOVA and Kruskal-Wallis test, they give the same result. You have seen that we have tested non-school, vocational and degree. We have compared it with the help of ANOVA. Okay, but strictly speaking, ANOVA is actually not very much suitable to compare this thing. Why? Because for in the case of degree, the income level, it has very high standard deviation. Okay, which is not around the non-school or variation level. It is 45384. Okay, so ideally speaking, instead of ANOVA, you should perform here Kruskal-Wallis test. But even if you perform Kruskal-Wallis test, it will provide you the same results as ANOVA. Okay, so this is all about the one-way ANOVA. Okay, in the next class we will discuss about the two-way ANOVA, and also two-way MANOVA we'll discuss. But three-way ANOVA or more than three-way level, we don't need to discuss. You can simply, the same way it will be done. Okay, you just need to use the software to perform this. Okay, so now I'm going to stop the recording.